Thank you so much for clicking the link of this video. My name is Jarno Baselier and this video marks the start of the AI Red Team Academy course. And in this course we are going to talk a lot about AI and hacking. We will start off from the absolute basics. So I will teach you what AI actually is. I will teach you how AI works, what the fundamentals are, what the terminology is, what large language models are, how they work internally, how they are trained. And once we have the basics in play, we will continue on attacking AI, because that is something that the customer usually asks of us, of the things that he needs us to do. He wants us to see or to check if the AI system or the AI agent or the AI large language model that the customer is using, if that part is safe enough to use in production. And you as a red teamer need to fully understand how you can check those systems and what the most common vulnerabilities in these systems and in these system chains are. And that is absolutely something that I will teach you during this course. So again, this is the first part of this course. All the other parts, and there are quite a lot of them, all the other parts I will also post absolutely for free on YouTube. But keep in mind, there are some additional extra workshops, some additional extra explanations, etc. that you can register for. Those are not for free, but most of the content is for free. So I hope that there is a lot of valuable content in here for you. And as you may have noticed, English is not my native language. My native language is Dutch. So please, if you subscribe to my channel, keep in mind that you will also get the updates about my Dutch videos. But don't you worry, I think they are also pretty interesting for you. And you can use the English subtitles to follow along. So maybe that is something you may want to take a look at. But for now, this complete course, the things and the videos that I am posting here on YouTube are absolutely free. And English so easy to understand. At least I hope I am easy to understand. That's all actually for now. So as usually on YouTube and all the shenanigans, just like this video, like all the other videos, and subscribe yourself to my channel, which is very important. Again, you will be notified by all the videos that I am publishing. So also all the new videos about the AI Red Team Academy course. That's important. And then, well, for now, let's just start with the first chapter. Let's start understanding AI and continue hacking AI systems. Welcome to the AI Red Team Academy, where you build AI skills and improve your red team tactics. We are at the first lesson, basic terminology, in phase A. And phase A are all the fundamentals. I can show you a little overview of all the lessons. And we have multiple A lessons, 8 of them. And these are all fundamentals. And once we have the fundamentals in play, we go to practical ML, machine learning, RAG systems. This is Dutch. It should be safety. Then we have agents, red teaming AI, and that's the last part of it all. So we start at phase A and we work through phase F so we can start pen testing. And the thing about fundamentals is basically that it is all about slides and theory. So I'll try to make it as dynamic as possible, but there are still a lot of slides we need to do. Every lesson has a lot of slides, but in future lessons, we can maybe play with some scripts, show some examples, etc. But since we are still at the fundamentals level, we just need to, you just need to learn a lot of theory and concepts. So that is exactly what we are going to do during this first lesson. And talking about AI, let's start talking about the basic terminology. First off, since this is the first lesson, who am I? For the people that don't know me, my name is Jarno Baselier. I'm 44 years old and I live in the Netherlands. Like I told you, English is not my native language, that's Dutch. And I work as, well, quite a few things. I am a CSERT lead, but also I am a red teamer, a hacker, and I specialize in a lot of parts like industrial automation and artificial intelligence, but I am a hacker for about 12 years now, and I started off as a system engineer. I have a lot of certifications, all on the red team side, so you can check my LinkedIn if that's interesting to you. And well, a little bit private, I am a security blogger since 2014, so quite a long time. I make video content since 2020, so if you visit my YouTube channel, there will be a lot of videos available. If you are Dutch speaking, it will be easy. If you are English speaking, you can choose to enable the subtitles if you want to follow along. Luckily, this course is fully in English. I'm a security trainer since 2023. I am a regular capture the flag player, although I have to be honest, I think like since 2 or 3 years it is a little bit less than what it was used to be, but still I like playing capture the flags, and I have written or co-written a few hacking books. Then I am married. I have two children in the age of 16 and 18. We have a dog, and of course what I really like are computers and technology. Music is something else that I love. I like to fly with drones, with FPV drones. Gaming is something that I do sometimes if I have the time, and then I like to ride a motorcycle or practice jiu-jitsu or just being at the gym. Well, that's a little bit about me, and I will be helping you through all the videos and all the information. The goal of this course is to gain a deep AI knowledge, how AI works and how to make it work for you. And then if this is all, well, these are basically the fundamentals, then you might want to have a fine-tuned model or a fine-tuned agent, something that does exactly what you want it to do. We want to be able to use AI and LLMs locally, but also and on-premise, but you also can use a cloud-based AI and internet-connected AI. It all depends on the use case. We have some tools. We will discuss some sandboxing later on. But most importantly, when you know what AI is and how it works, are the security and the red teaming perspectives. How does a hacker look at AI and AI systems, and what can we do to break and test these systems? So the offensive research. And then the goal of this module is to explain what AI, machine learning, deep learning, and large language models are, and how they relate to each other. To understand the different learning paradigms like supervised, unsupervised, and reinforced, recognize common challenges like overfitting and generalization, and use correct terminology confidently in conversations, research, and documentations. Be assured, we will talk about a lot of terminology. We have some required materials that you need to follow this course along. Well, simply set a computer with internet and basic tools to follow this course. Additional, a ChatGPT, a Gemini, or a Grok or Cloud Pro subscription that can help you. This isn't required, but it is something that might be helping you to create scripts, etc. that you might need. Then also additional is a special AI workload handler like a dedicated machine or a cloud instance. You can do most of the things on a normal computer, even in a virtualized machine, but to gain speed, you might want to use a special AI workload machine. And most importantly, you need to have the desire to learn and to embrace the journey. That's absolutely required because, again, a lot of slides, a lot of theory, a lot of things you need to learn, and a lot of things we are going to do. AI is software that learns statistical patterns from data during training, then makes probabilistic predictions or decisions during inference. AI is not intelligent. It looks intelligent, but it isn't. It's a pattern matching calculator. Feed it clean, structured data and you will get a reliable output. But feed it noise, bias or crafted adversarial inputs, then it breaks in predictable and exploitable ways. From a red team view, every model has a training phase. You can poison, an inference phase, you can jailbreak, a confidence scores you can manipulate. So master the data, master the model, and only then you can master its power for your own gains. Then what is artificial intelligence or AI? And we will take a look at the cat in the photo. When you spot a cat in a picture, you know it is a cat because you have seen the pattern before. You recognize a cat because it has whiskers, ears, tail, etc. And AI does basically the same. Feed it thousands of cat photos and it learns the pattern too. At its core, AI is software that recognizes patterns in data and makes calculated decisions based on them. It learns, it decides, it recognizes, and writes from information you give it. AI is not magic. It is not all-knowing. Garbage in is still garbage out every time. We have different styles of AI and we will discuss these three. We have narrow AI, general AI or AGI, and super intelligent AI. And everything we use today is narrow AI. So as of this moment, no true AGI exists yet. So general AI is something we might see in the future, and super intelligent AI maybe in the far future, but not in the near one. So narrow AI is AI built for one specific task, like chatbots, face recognition, spam filters, etc. Talking about general AI, that's AI that can learn any intellectual task a human can. But this does not exist yet. And even better, super intelligent AI is AI that surpasses human intelligence in all domains. So this is a hypothetical future scenario. An AI model is essentially a pattern calculator. When we feed a model 1000 cat images, it learns from this data and can or cannot answer the question if a new image is a cat or contains a cat. And that's what we see in the schematics below. Feed 1000 cat images to the AI model, then feed it a new image, and the AI model will predict if it is a cat or if it's not a cat. Simple as that. We also need to talk a little bit about machine learning. Because machine learning and AI are not the same, but they are very close related to each other. Machine learning is a subset of AI where systems can learn patterns from data instead of being manually programmed. Instead of writing rules, we let the machine learn them from examples. And here as well, we have some types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is labeled data. Input plus correct output. And as an example, we might have spam detection. We feed it 1000 emails. We tell exactly which email is spam and which email isn't. And in the end, it will learn what spam is and what is not spam. Then we have unsupervised learning, which is used when we let it learn from unlabeled data. So we won't tell which answer is correct while giving the data. And one example is customer clustering. For instance, we give you 1000 customers and you will cluster these customers into different kinds of groups. And we will only tell you when you make a mistake so you can correct it. But basically this works with unlabeled data, and we have reinforced learning. And this is rewarded from trial and error interactions. So like game playing bots, like AlphaGo. So when we have a game playing bot and the bot is controlling a character and the character dies, that is basically an error and it is not rewarding in any way. When the character lives, then it is being rewarded. So the model knows it did something right and it will redo the same thing again next time. So here we have supervised learning explained, where we do give the answers, and this is the exact same example as we talked about for the emails. We give it emails and we tell it which is spam. We will put this in the training phase and this will create a trained model. So now a new email comes in and the trained model will analyze this email and it will detect if it is spam or if it is non-spam. Unsupervised learning, is where unsupervised is detective without briefing. So this is great for anomaly hunting in red team logs. We have 1 million logs with no labels, and then the model finds different clusters, attacks from RU, normal traffic, and weird spikes. But because we give it a lot of data, it can create these clusters and set the logs in the right clusters. And the last one is the reinforced learning, the trail and reward. Reinforcement is learned by playing, so after 100,000 attempts, it can create a perfect exploit. This is in most ways the red team's secret weapon, and we see a simple example. Here we have a fuzzing agent where we will try a specific payload to a target system, and well, maybe the target system crashes, and then we will start over again with the next payload with the information that if we did the previous one plus 100 it crashes, but with -1 it is still alive, and we will adjust the payload just until it is perfectly and the target is, well, in this case is being hacked. But this is just a simple example of a fuzzing agent learning by trial and error. Then talk about deep learning. Deep learning is a special and advanced form of machine learning. It uses so-called neural networks with many layers, and a layer is a group of neurons. A neural network are stacked layers working together, and this is used in speech recognition, self-driving cars, and in large language models, LLMs. And we see the basics. Here we have some inputs at the input layers. Those have some specific scores, and this will go to the next layer. The next layer will score the input as well, and based on all the scores, when we reach the end or the output layer, we have some defined output. So a neural network is a stack of math equations that turns raw input like pixels or text into a useful output like cat or exploit works. It learns by adjusting millions of tiny dials, we call them weights, during training. A weight is what the network actually learns. So again, we have the input layer where the raw data enters, and in this example we have a cat image, so this has 748 pixels, 28 by 28. Then we have multiple hidden layers, and these will extract different features. So layer 1 will extract the edges, layer 2 will extract the eyes, layer 3 will extract the whiskers, and then we have the output layer which shows the final decision. And in this example we have a few numbers, and checking those numbers it will show that the animal in this image is probably a cat. And schematic, this looks a little bit like the schema below, where layer 1 detects the edges, layer 2 detects the shapes, etc. And finally we get an output, and the output tells us that the image or the data that we fed to the LLM or to the neural network is most likely a cat, and in this example it is 89% sure that it's a cat. And here we see the same thing as well. We have the input layer again, two hidden layers and an output layer, and it makes a lot of decisions when data travels from the input layer to the output layer, and the output layer simply shows us the highest score of the most probable match. Checking the red team status, the red team truth in this. Know that weights are just numbers. So poison training data and you will create a backdoor. The hidden layers are basically a black box. We know what we put into the network, and we know what we get out of it, but what happens in between is a black box. So if the adversarial can use the hidden layers to make a 1 pixel change, we can fool the model. So if that's the other way around, if an adversarial user, if a hacker inputs an image and changes 1 pixel in the image, this might fool the model. Because what happens in the hidden layers again is black box, and hackers simply test for weird outputs. More layers means more power, but also more GPU needed for an attack. But break one layer and you will break the complete model. Keep that in mind. We have some deep learning variants like RNN, the recurrent neural network, CNN, the convolutional neural network, and we have transformers as well. An RNN is best at processing sequences. This is older and struggles with long context. A CNN is best at images and vision, and this is still widely used in computer vision. And then transformers, this is what modern LLM use, is best at language and multimodal tasks. And what multimodal is, we will explain this a little bit later. Transformers replaced RNNs because they use self-attention. They can understand relationships between words regardless of distance. Longer context understanding, they have faster parallel training, and they have a higher accuracy. So an RNN, if we check the attack surface of an RNN, which is used in time series and logs, we can poison the sequence and break the memory this way. But looking at CNNs, we have a different attack surface. CNNs use at images and PCAP heat maps. The attack surface here is an adversarial pixel, which might fool the detector and give a different output. And then we have transformers used for all LLMs, RAG and agents. Another attack surface here is prompt injection, maybe jailbreaking the model or performing a data leak so we can gain data that we weren't supposed to get. All different attack surfaces for all different network types. And here we see again the different kinds of network types, where they're good at and what the potential attack paths are. And now we reach the large language model, and be assured that if this all looks like different kinds of terminology, the way how they fit together, we will absolutely take a look at that on how it all fits together. But for now, you need to basically understand what all the differences are and what they mean. And in the later lessons, we will make sure that everything that we teach right now will fall like a puzzle into play. A large language model, a transformer model trained on massive amounts of text to predict the next token. Keep that in mind, predict the next token. A token is the smallest unit the model sees. This is not a full word, but a chunk of text. LLMs do not think, they statistically predict the most likely continuation of text. So we have some example text, in this case, hello world. And the model might break it down into 3 tokens. Hello, world, and the exclamation mark. Waterschap.nl, which is a Dutch word, might be 4 tokens. And there we have an emoji. And an emoji in this case is simply 1 token. Because modern tokenizers handle emojis pretty well. Why do tokens matter? This is a red team view, of course. Context window. A model can have a context window, and a context window is the maximum amount of tokens it can handle or process. Grok, for instance, has a token window of 128,000 tokens. The attack surface here is simply prompt stuffing to overflow memory. If we give it more data than can fit in the 128,000 tokens, memory might overflow. Tokens are also matter because of cost, because we pay per token. For instance, we might pay like $5 for 1 million tokens. So they are used for payment. And in this case, we can perform maybe a denial of wallet attack, where we can simply give it so much data that a wallet of, money, the best way to explain it is simply a wallet of money, an account where you drop money to use. You see this a lot of times in pro subscriptions for like ChatGPT. You get access to so much when you buy credits. A credit stands for so many tokens. So when you use those tokens, 1 credit will disappear from your wallet, and this way you can make an amount of requests. When an attacker makes just more amount of requests, then your wallet will be empty and you have no money left. That's a denial of wallet attack. And finally, the model predicts 1 token at a time. So we can jailbreak through token level manipulation. All of this we will explain in later chapters as well. So checking the differences between a general model and a large language model. The definition of a normal model is any system that learns from data to make predictions or decisions. For a large language model, a type of model with billions of parameters trained on massive text to generate human-like language, which is the main difference. The size, a normal model can be very tiny to pretty huge, but a large language model is always large. A 1B model knows 405 billion parameters like GPT-3. No, it can be 1 billion parameters to 405 billion parameters. And bots like GPT-3, Llama and Grok all have a lot of parameters, so they are pretty big large language models. The training goal for a normal model is any classify, detect, control or play games. For a large language model, it is always next word prediction on internet scale text. As an example, for a normal model, it might be a cat detector, which will use CNN. It might be a spam filter or a fuzzing agent. And as an example for an LLM, it will be ChatGPT, Grok, Cloud, Llama 3. Well, I guess you know them all. Architectures, well, normal models can be CNN, RNNs, decision tree, etc. But for a large language model, we talk about transformer based with attention layers. The input and the output of normal models will be images, logs, numbers, and the output can be any. The input of an LLM and the output will both be text. For a red team risk with a normal model, that's data poisoning and adversarial examples. For a large language model, it will be prompt injection, jailbreaks, hallucinations, and data leakage. We talked about training the model. Well, then we also need to talk about datasets. And a dataset is the text used to train the model. Normal models and large language models. The goal in AI is generalization, so no overfitting. Well, what is generalization? Generalization is that it learns the patterns that apply to new data. This is basically equal to a student who understands the concept, who makes the right decisions at the right time to get the right output. Overfitting is something we don't want, because overfitting, when that happens, then the model memorizes the training data. And this is equal to a student that only memorizes the exact answers. And this is not what we want, because it is not a FAQ, it's not a question answer model. It's a model that needs to make decisions, and to make decisions you need to understand topics. Again, looking at the model type, looking at a LLM. As a dataset example, we can have a common crawl of the internet, which might contain trillions of words. The purpose of this is to train the next token prediction for chatting and coding. If we talk about a CNN or images, then the dataset example might be the MNIST, which contains 60,000 handwritten digits. And the purpose of this is to learn to classify images. An RNN or sequences, as a dataset example, we might give it stock prices. And the purpose of this is to predict trend or log anomalies. And for a general machine learning, we might have an iris, which is 150 flower measurements, for the purpose to learn basic classification. For example, to specify the ID. Red team truth, the data set is the real model, so everything else is just math. Keep that in mind. We have different data sets used to create a model. The training set, the validation set, and the test set. The training set is how the model learns patterns. And the validation set is used to tune the settings without cheating. And the test set is used to evaluate the final performance. So here we have a full data set of 10,000 labeled emails, where 80%, so 8,000 emails, will be a training set, 10% will be the validation set, and 10% will be the test set. The training set and the validation set will both be used to train the model and adjust the weights. Then we have a final evaluation with a high accuracy, and this will be tested with the final test set. That's how models are trained. Talking about a bias, something what we need to understand is that a bias in a neural network is a trainable constant value added to a neuron's weighted input before the activation function is applied. A bias allows a neuron to learn patterns active even when all inputs are zero. So without a bias, a neuron's output would always be zero when there would be no input, which limits what the model can learn. And here we see basically the same, the analogy. We have a weight, which is the volume. We have a bias dial, or the activation meter. And the bias is your personal eagerness to listen. This is the threshold. A high bias is an optimistic listener. A low bias is a skeptical listener. And here we see the formula where W is the weight or the strength. The X is the input and the B is the bias, which shift the line a little bit up or down, and that's what you see here. Without a bias, the line is flat, and with a bias, the line is not 100% flat anymore. Keep this analogy in mind, it will become important later on, but that is the role of a bias. Some other terms you will hear and learn are agentic AI and multi-agent systems. Agentic AI is the autonomous worker. An agent is a combination of a large language model, tools, memory, and a specific goal. A multi-agent is a team of specialists or a team of agents. So for red team usage, we can use agents to perform auto pen testing, auto reporting, auto escalation, etc. So one agent is a smart assistant, but 10 agents is an autonomous red team. Keep in mind that during this course we will mainly focus on the following AI concepts. Those concepts are the most important to us as a red teamer, and to understand the concepts we will use narrow AI. So we will only look at what we can build today, not what might be there in the future. We will also use deep learning. This is the method behind modern AI training. We will use neural networks, the AI model itself. We will talk about layers and weights because this is where the AI's knowledge lives. We will use transformers, the architecture powering modern LLMs. Of course, we will use LLMs because these are the models that understand and generate language. We will talk about datasets because this is how we train or fine-tune our model on our specific data. And we will use agentic AI. This is the end goal because AI that thinks, acts, and execute tasks is a very powerful tool or a very powerful AI. And this is the end of the first module. This is the end of all the basic theory. And I hope that you already learned a little bit about everything. And it is still interesting and appealing to you to start the next chapters. Because in the next chapter, we will absolutely expand all the knowledge that we have gained so far. So yeah, thank you so much for checking out this first module. I hope to see you again in the next one. Because this is a YouTube video, please like the video, subscribe to it, and share it in your own network so it gains more traction and I simply get more viewers. Know that it took a lot of free time to create this course. You will see how deep we will go, how many slides that needed to be created to explain all the content. So please reward the effort and like, subscribe, and share. And of course, you can leave nice comments below, and I will do my utmost best to answer all the questions that you might have. Again, thank you so much for watching. Hope to see you in the next one. Have an amazing day and love to see you next time. Bye bye.